folks, I'm Ravi and I work with Yral as a developer. Yral is a short video social media platform built on internet computer and is powered by Rust. As a team, we have made a lot of technical advancements in past few months. I wanted to discuss one of those today. Before we move ahead, I want to clear few terms that I might be using frequently during the presentation. IC or internet computer have subnets and canisters. I'll not go deep into explaining them, but for our use case, you can consider subnet is a collection of interacting replica that runs a separate instance of the consensus mechanism in order to create a blockchain on which our canisters are deployed. Canister is a smart contract. In Yral, we allocate one canister per user. So that means every user has its own isolated data. With this being clear, let's move ahead. What we had earlier is a single subnet architecture. That means all user canisters were on the same subnet. This presentation is to discuss the changes we made moving from single subnet architecture to a multi-subnet architecture. Let's pause and look at what were the challenges with the previous architecture. And to do that, we need to have a look how did we allocate canisters to a user in a single subnet architecture. We have this subnet orchestrator canisters which is deployed within a subnet and it manages all the users in that subnet. That means handling code upgrades, topping up user canisters, spawning new canister for a new user. And this is the flow when a new user comes. User comes in, requests for a canister from subnet orchestrator. Subnet orchestrator creates a new canister, installs the WASM, gets the canister ID, and the canister ID gets returned to the user, and then subsequent calls are made to the individual canister. But this architecture has a set of challenges. First, the subnet can only accommodate 50,000 canisters. We had already reached this limit, the very reason we had to stop the signups on Hot or Not. Second, creating canister is an intensive operation, and creating canister as and when user requests it becomes a bottleneck. Third, moving canisters to different subnet in case where load increases on a subnet. Well, you can't do in this architecture, you only have a single subnet. So what's the solution? You deploy canisters to other subnets, simple, right? Well, in that case, we need platform orchestrator canister, which now manages all the subnet orchestrator from different subnet, which in turn manages all the user canisters in a particular subnet. Before we move on to the allocation of canisters in this architecture, let's look at how do we provision a subnet orchestrator. Provisioning a subnet orchestrator on a subnet means now we can use it for deploying our user canisters on that subnet. So a subnet is decided and through SNS proposal is submitted to the platform orchestrator. Platform orchestrator then creates a new subnet orchestrator on the subnet and installs the WASM for subnet orchestrator. It also creates a pool of X individual canisters in the subnet and Y empty canisters. Now this X individual canisters have code installed but have not been assigned to a user but are ready to be used. And Y empty canisters are reserved as backup. You will get more clarity on this in coming slides. And then it returns the subnet canister ID. Look at these graphs. It might look familiar. This was a few weeks ago, the cycle consumption just shot up. Well, we are the culprits. We were essentially deploying subnet orchestrator to every subnet in the IC. So we were essentially doing this flow on every subnet. Let's look at how do we allocate canisters for a user. User comes in, requests a subnet orchestrator from platform orchestrator. Platform orchestrator returns a subnet orchestrator which has some capacity left. User then goes and asks subnet orchestrator for individual canisters. Subnet orchestrator assigns an individual canister immediately from the pool of X individual canisters. Remember the X number of canisters from the subnet orchestrator slide? Meanwhile, if necessary, subnet orchestrator will install code in empty canisters and keep it ready for future users, and will also provision new empty canisters as backup. It returns the individual canister ID, and then subsequent calls are made to the individual canister. This concludes today's brief presentation. We have several other technical updates, including our seamless authorization feature and our new web application powered by Rust and renowned for its blazing fast and snappy performance. With all these features, Yral is capable of accommodating million users. Stay tuned for exciting updates. Thank you.